Okay, this is day 36, factor by grouping. Okay, so this is like what we did last week. So, except it's going to be a little bit different, but it won't be that much different. So it'll be easy. I know it's going to be easy for you because we've learned the harder way of factoring. So remember last week we had like x squared plus, let me see, let me pick a good number, okay? Okay? Yes? Remember doing this? What would I break this apart to be?
X plus 8 times,
8x.
X plus...
Plus what?
8.
Yes? And then we did this grouping thing. This has been a common thing, this grouping thing. Yes? And then it becomes what? X plus... What's our final answer going to be?
X plus 8.
Times x plus 8. Yeah, or x... Nah, that's not right. X plus 1. Yes? Do you remember this? Okay, good. That's like a double parenthesis there. I don't know how that happened. Let me fix that for us. Okay, so today we're going to do the same thing, except... What's going on here? Except check this out. You see on this first example I have a x squared here, okay? This is a quadratic equation, okay? Don't get freaked out. But we can do the same thing on larger equations. So let's say we have something like this, x to the fourth. Oh, not x to the fourth. X cubed plus, I don't know, 8x squared plus 4x plus 1. Okay? We're going to do the same exact thing. Okay? You see how it's x cubed here? So we could still do this grouping thing. Okay, now I'm going to talk to you about that today. That's the big idea. Okay? Make sense?
Yep.
Okay, cool. Okay, if you're on the video, here are the steps. Same idea, we want to look at our GCF, factor by grouping, and move on with factoring, okay? Numbers 1 and 2. Okay, here we go. First thing I want to do, number 1, 14k cubed plus 12k squared plus 7k plus 6. Okay, eyes up here, please. Okay, so the first thing I want to do is, I notice it's k to the third power, and we have k squared, k, and then constant of 6. It's in descending order, and then I'm trying to see if there's a GCF that goes out of all of these, okay? This one's even, this one's not even, so now I can't take out a GCF, okay? They all also don't have k, so I can't take out a GCF. Eyes up here right now, okay? I'll make sure you get this, all right? So I'm noticing patterns, though. I know that 2 goes in the 14 and 12, right? You see that? And 6. But I also notice that 7 and 14. What's the GCF of 7 and 14? 7, right? And 12 and 6, what's the GCF of 12 and 6? So I could rewrite this to make it a little bit easier, I feel like. So I'm going to put 14k cubed plus 7k. And then I'm going to rewrite this with 12k squared next to positive 6, okay? I didn't change my problem at all, I just changed the order of it, okay? And then I'm going to do my parentheses like I did last week, okay? Put a plus sign in the middle, and I ask myself, what's the GCF of 14k cubed plus 7k, everyone? What? 7k, good. So then I open parentheses. I know I could take out 2k squared here when I factor it, right? 7k times 2k squared is equal to 14k cubed. 7k times positive 1 is equal to 7k. Then I'm asking myself, what's the GCF of the next binomial, everyone?
6.
Positive or negative 6?
Positive.
Positive 6, okay. So positive 6 times 2k squared plus 1, right? And then I'm like checking my work right now because I know that this should be the same as this. And they are, you see that? So then I can factor 2k squared plus 1 out. Right? Hopefully we all remember that. And then we have, we could take out, bring down 7k and plus 6. And then we're done. Right? So, this is kind of like last week, right? Isn't this just the same thing?
Yeah.
Yeah. Totally the same thing, except we don't have to make 2 new middle terms. We're just factor by grouping. Okay? So that's number 1. Watch we do number 2. Number 2, 24x cubed plus 21x squared minus 64x minus 56. Is there a number that goes into all of them?
Yep.
What?
No. 7. No.
7 doesn't go into 24. 4 doesn't go into 21. 3? 3 doesn't go into 56. Is there a number that goes in all of them?
No.
No. Okay, cool. So is there a way I could regroup these maybe?
No, it's no solution.
No, there's a solution.
24 and 64 and 24.
Well, it goes into both 24 and 64.
8.
Okay. Cool. And what else can I put together?
21 and 56.
What goes into both of those? 7. Okay, you can regroup them. That's a good strategy. We don't have to necessarily regroup them. On this one, I'm going to show you that you don't have to. So I'm just going to keep it like this. Watch this. What goes into both 24 and 21? 3. Good. What else goes into all of this? What? X squared. Good. So watch this. I'm going to go x squared. 3x squared times what is 24x cubed? 8x. Good. Okay. 3x squared times what is positive 21x squared? Positive 7, right? Aren't these the numbers you were talking about a minute ago? Right? Okay, I'm going to put the plus sign here for parentheses. Okay, what can I take out of the second binomial? What kind of 8? Negative 8. Right, so it's going to be 8x plus 7. Y'all see that? Yeah, so we could have regrouped. We could have done that and still got the same answer, okay? So checking my work now, I know that these two are the same. So now I'm going to rewrite this as 8x plus 7 all times 3x squared minus 8. And that's it. I'm done. Does that make sense, everyone?
Yeah.
Okay, good. So is this much different than last week? No. Okay, so these are more complicated problems, okay? But since we already know the skill of factor by grouping, this is super easy to do. Okay, so what I'd like you to do today, it's Monday, so let's switch things up. Let's have 4s talk today first. 4s are going to teach the rest of the group about number 1. 2s are going to teach, 4s are first, and then 3s are going to teach the rest of the group about number 2. If you don't have a 4, let's have a 2 talk for a 4. If you don't have a 3, let's have a 1 talk for a 3. Ready, set, teaching time. Go. There we go. Number 3. Okay, let's write down number 3 in our notebooks, please. Let's start working this out. All right, so as you're writing this down, turn your neighbors in your group and talk about a strategy of maybe a way you could rearrange these numbers if you can. All right, kiddos, what can I rearrange? Okay, 12x cubed and what?
4x.
Plus 4x. Okay, like this? Yep. And then we're going to bring down the 21x squared and the 7, okay? So let's have you finish up the problem. You can do some math chatting if you need to talk about the problem. We're checking our work now. You should have taken out a 4x. You should have taken out 4x first. So you got 3x squared plus 1. Then we should have taken out positive 7. So you got 3x squared plus 1. Checking these two, they should be the same at this point. Times 4x plus 7. Does that make sense, everyone? Yes or no?
Yes.
Awesome. Next one. Exactly, awesome sauce. Number 4, go. Number 4. On this example, I noticed that everyone had the right answer. Now, raise your hand if you rearranged the numbers the first time. The first step, you rearranged. Okay, so check this out. You don't have to rearrange. Eyes up here. I'm going to get you the same answer, so instead of rearranging, you could just start working here. Is there what's the GCF of these first two numbers, everyone?
15.
No, 5p squared. Okay, 5p squared times 3p is equal to 15p cubed. And then times positive 7 is equal to that, right? What's the GCF of the second term, everyone? It's just plus 1, right? Yes? What's 1 times anything? Itself, right? So, y'all see that? So then these are the same. You got 3p plus 7. I wanted to show you a different way of doing it. Same answer as what you all got, right? Okay? And that's it. Any questions so far? Yes or no? You good? Okay, cool. So I think I'm going to conclude the lesson there. We're done. Because you all got it. You're all doing a really good job. So I'm not going to have you keep working here. So that concludes the lesson.